welcome to the Grace Shaw channel. And today we are going to be talking about budget constraints. We all know what a budget is. Maybe we don't use one, but we all know what a budget is. And for the sake of argument, we are going to pretend that we all budget for every little detail for our income. So, what are the three things that you need in order to create a budget line? You need a budget, how much that you're capable of spending on that or wanting to spend, the price of the first good and the price of a second good. In budget lines, we compare two different items and see what combinations that we can acquire of those within our budget. So for those of you who like to look at mathematically, our budget line is the price of good one times the quantity of good one plus the price of good two times the quantity of good two has to be less than or equal to our budget. So let's take a look at an example question. Suppose Parker Gibbs has an income of $30. Parker derives satisfaction from the consumption of tea and biscuits. The price of tea is $3 per cup, and the price of biscuits is 50 cents per unit. In other words, per biscuit. So we are going to graphically construct a budget line for this situation. And make sure and label your axes carefully. So what is the first thing we do in any problem? We write our formula down. And this is the one that we just seen in our budget constraints overview. That is the very first thing. Write your formula down so you know where you're going with a problem. Next, let's take a look at different ways to look at this problem with this equation. First, I would make a table, such as the one I did here. And our tea is $3 per cup. So I would type that in. $3 times the quantity of tea, and it's 50 cents per the quantities of biscuits, is going to be equal to $30 or less than. So for sake of argument, for mathematical reasons, we're saying equal. In other words, we know we can't go over that $30. With creating a table such as this, you will be able then to eventually be able to graph your data. So let's do some calculations here. So first, let's just say, in order to graph, the easiest way is to put a 0 in for each one of these, and then calculate out how many of the other goods that we can have. So if we had 0 teas, all of our money could be spent on biscuits, a whole $30. And they are 50 cents a piece, so we can have 60 biscuits. And the same goes for tea. All of our money, if we're not spending anything on biscuits, can go to tea. Tea for each cup is $3. We are budgeted $30. That means we can have 10 cups of tea for that. So next, we will be graphing this. And first, we need an X and a Y lines for a graph. So we have a graph here, and we all know that X is here and Y is this side. We're going to label this, and let's just start with, I'm going to put quantity of tea here, and down here we're going to do the quantity of biscuits. I'm going to abbreviate here for you. And so then we graphically would put this on here. So we have 0 T's, which would be here, but 60 biscuits. So let's just say 60 is roughly here. We're going to put 60 here. So that's our point A. Another point is on a graph is 10 T's and 0 biscuits. So 10 T's, we'll just say is up here. And 0. So now we can connect this, creating a line. Now that is your budget line for this problem. We have a budget of $30. We can either spend $60 on biscuits and nothing on tea, acquire 60, or 10 teas for $30, or any other combinations that would fall on that line because we are equal, or below it. So anything in this area here, we could also have. Okay? So let's take a look at another problem. So we are looking at the same scenario, but let's just suppose the price of tea increased to $5 a cup instead of the $3. So this problem is saying his income has remained the same and the price of biscuits are remained the same. So the only thing that has changed is the price of tea has increased here. So price of tea has increased to $5. All other things have remained the same. So they want you to redraw a budget line to reflect this situation. So remember, the first thing you're going to do is put a formula down so you know what you're working with. Next, let's create a chart before we can do a graph. We know our tea is $5 now, and our biscuits remained at 50 cents, and our budget is still the same at 30. So from here, why don't you pause the video and figure out what your extremities would be by inputting zeros for tea and a 0 on the biscuits. And let's see what your calculations come up with. You should have came up with 60 biscuits if you're going to have 0 tea, or if you don't want any biscuits at all, you can have 6 cups of tea. So let's pause the video a moment and see how your graph comes out. Okay, so your graph should have came out something like this. Your pinpoint for quantities of tea is 0, and biscuits are 60, which would give you down to this point here on the bottom of 0 and 60. Then, if you had 6 cups of tea and 0 biscuits, you would find yourself up here and draw the line in between. So that would give you your chart, your graph for this, and make sure you have labeled your X and Y with appropriate labels of making sure that you use the word something that refers to quantity, not price, but quantity, because we are trying to figure out how many of a good that you can have for a budget. So this is quantity, not your price. So making sure that you use direct good labels. So next, let's compare these two budget lines. Let's take a look at what this actually means. So I have brought over in blue the first scenario we looked at where tea was $3 and our green that I've colored is $5 for a cup of tea. And as we know, our biscuits are 50 cents in each of the two scenarios, and our budget is less than or equal to $30. So I have already put these two together. And as we see that our blue, where our tea is 30, I have labeled A, B line. And then our green, where our cup of teas are $5, is our BC line. So, as you kind of can see that if we have a point of intersection, which both of these points is 0 and 60, actually, it would be 60, 0 if you're writing coordinates out. I labeled it B, and there's only one letter there because that is the same coordinates used for both lines, so we can use one letter. So as you see, as price changed of tea, we had a shift here in our line. Our line shifted downward in this. It shifted down because our quantity of tea decreased. Now, this would change if we had different lines. Our different price changes, up or down, they would change. But in this case, we had a shift in the price of tea because it only shifted on the y-axis, not the x-axis. So, this is Budget Constraints by the Grace Shaw Channel.